0.3 pounds. That's the resolution that I get from my 2,500 pound load cell is about 0.13 pounds. Now, my load cell is 0. The displacement, I do not have to worry about it. Now, the cell pressure and the sample pressure that they're coming from the flow pump, we have cell pressure and sample pressure. Now, the 0 for that right now is reading about something 0.5 psi for the cell pressure and about 0.3 for the sample pressure. The standard says is the actual 0 for your pressure is mid-height of the sample. So right now what we have the two flow pump with the output valves open. So the output valves are open, lines are filled with water, and then what I'll do, I'll go right here and I hold them halfway, mid-height of the sample. So I hold that, make sure there's no air trapped here. So this is my level of water right halfway, and I'll hold it here. I got Steve graciously volunteered to hold it for that. Now I go back here and I look at my cell pressure and my sample pressure. I go back to the calibration summary. I go to the cell pressure and I change my offset to the one that I read now for mid-height of the sample, 32862. I do apply, download, now it's 0. And I do the same thing with the sample pressure, is 32908. I do apply, download, okay. Now, all my sensors are zeroed. I'm ready to run a triaxial test, but this is what is important, that you zero your pressure at the beginning of the test, because the height of the sample is going to vary, and also the platen position might vary a little bit. So you might have a small variation that you want to just check it, and that's a good way also check that everything is working. And that's how you zero your sensor prior to running your test. So what we have done is we had bled the lines, make sure there's no air trapped. And even if we find out there is some air trap, when we run the test, we can still get rid of the air inside. And we zero our sensors, and we're about ready to run our triaxial test. Okay, we're going to be running for demonstration a triaxial test. The triaxial test that we selected to run is the most common, the most popular test, is a consolidated, isotropically undrained with pore pressure measurement compression test. In short, they call it CU test, consolidated undrained. And so we're going to run this test. Now, this triaxial test is an involved test. It has different phases, and within the phases, there could be different steps. The three major phases in the triaxial are the back pressure saturation. So we want to make sure that the sample is fully saturated. And the second phase, or the phase that follows the back pressure saturation, is the consolidation. So the sample needs to be consolidated to the effective stress that exists in the ground. That's for the first point. And the third phase is the shear phase, where we're going to increase the vertical load at constant rate of displacement, and we're going to be measuring the excess pore pressure, the load, and the deformation. So this test has multiple phases in it. And now, traditionally and manually, people used to do it by hand, where they do the back pressure saturation using a manual panel with all kinds of manifolds and valves and burettes to keep track of volumes and pressures. After the saturation phase, they do the consolidation and the shear. The system here that you have, it does it all automatically. It goes from one phase to the next phase till the end of the test automatically based on the criteria that you have set in your software, or you can just use the default criteria. Okay? Thank you. Okay, we're going to run a triaxial, CU triaxial test. We have our sample is ready, our lines are bled, and what I'm going to do is I go into the software called Triaxial. I double click on that. Same thing as I did with my consolidation. You must always go to File and load the template file. So I got my template file here. And you need to fill in all this information. The most critical is the diameter and the height of the sample. So I am filling the information as best as I can. Water content, read table here, test parameters. So all this information, there are default information here. Okay, so all this information here, what I do first, I go to View, System Monitor, make sure that everything looks good. There communication between the hardware here and the software, which I can see it here. Next, as I said, lines were bled, and what I do, I connect my cell pressure and my sample pressure. Now, something very important here I need to mention is you have all these valves on the triaxial. Now the software does not know what's going on with this valve. So as a default, you have all these valves open except this one here. This one is open, and what we can do, we can use it to bleed or get rid of any air that is trapped here. So the first thing we can do is we can bleed the inside lines in the triaxial before we run our test. Okay, this video clip is going to explain how we're going to get rid of the air bubbles that they're inside the internal tubes here. So what we have here on the triaxial, we have the bottom and the top drainage lines, and they're bridged together with this line here. So I can push water from the bottom, and it comes out through the bridge line, and then it comes out until the end here. So what I'm going to do, I'm going to push some water from my bottom pressure until I see it coming out from the top. So I use the same technique here, which I have the output valve open, and I'm going to push flow out, and I can see the water is going here. It's going to go through the line here, come out this way, and eventually it's going to start coming out from this line here. So now it's just pushing air that is in the lines. I can see the air, and if I put it here, you can see it bubbling. Now here's the water coming out. So what is this water coming? What's the path of the water that is coming out? I'm pushing water from the pump through the output valve. The water is going in this line, going to the bottom of the sample, coming out from the bottom of the sample. There's a bridge valve here. It's going to the top, goes to the top, and it's going to come out from the last one. Now I have all the lines inside, outside here. They're all bled. There's water coming out, and I can just stop it. When I stop it, what I do is I close this valve. This is the only valve that needs to be closed for the triaxial. All these valves are open. So the valves are open. The valve control is done here to the software. The software does not know what triaxial cell you're using. You could be using any triaxial cell. Maybe it doesn't have valves. It does have valve. So by default, valve number 1, 2, and 3 open all the time for the triaxial. This one is closed. This one you only use it If you see air bubble, you want to get rid of it, then you can get rid of it. So that is the default position of the valves. And now we are really ready to run our triaxial. Thank you. Okay, we have get rid of all the air bubbles in the line, the outside, the inside, the internal lines. So everything is bled, everything is ready to go. That's my triaxial cell. As I mentioned in the previous video clip, the valves, they have to be open. The piston here is locked. The software is going to ask me to unlock the piston. The last valve here is closed. That's the only one that is closed. And it will remain closed during the duration of the triaxial test. So I have loaded my software and a template file. Everything looks good. I go into System Monitor, make sure that everything is on. There's a communication here. And I go to my project. I fill in all the information I need to, like the date, when this test is run, location, the tester, the checker, specimen information, water content, how I'm going to read the data, how I'm going to run the test, the parameters involved in the test. Now I have what is called initialization phase, which is something is not in the ASTM, but what I'm doing with the initialization phase is I'm applying small stresses on the sample to keep it together. And also the initialization phase actually has many benefits here. Now the first thing is to keep the sample together. Second one is make sure that everything is working properly before I run the full test, so I don't mess up my sample or bust the sample. Sometimes you only have one sample that you're going to test, and some of the samples are really expensive. If you bring a sample on offshore, it might cost $10,000 to get the sample, so you only have one shot. And this initialization is very important. So if the system cannot maintain 1 or 2 psi small pressure, then it won't maintain bigger ones. So initialization, I put a vertical stress, a horizontal stress, and a sample pressure. And also, more importantly, this is where I can detect if there is a leak. If there is a leak, and as I mentioned before, 90% of the problems with the triaxial are leak related. And this is where I can catch it at the beginning. If I put 1 psi difference between the outside